So these first two are the same type of question. You have a function and you're deciding which approximation is bigger than another. So what I'm going to do is draw a picture of this and kind of put them all in order. And I haven't put midpoint sum on here. It's just going to be left, right, trapezoidal, and then like the actual area, because it's so hard to tell with midpoint. So that's not going to be on there. Right, so I'm going to draw a picture of this graph just to get a visual. It's an upside down parabola. It went right 2 and up 4. So I'm going to go right 2, up 4, put a point, and it's going to go something like this. So let me plug in a few more values just to get some more points here. So let me plug in 3. That's going to give me 3. So I'll have a point here and here. And then if I plug in 4, 4 minus 2 would be 2, squared is 4, negative 4 plus 4 will be 0. So that's going to be 0. So it'll look something like this. And we're looking at this on the interval from 2 to 4. So we're only looking at this part of it. So you have to kind of ignore the rest of it and just look at that part that I've shaded in there. So that's the area that we're looking at. So this part of the function, it's decreasing and it's concave down. So what I want to do is put all of the sums and the true area in order, smallest to biggest. So since this is decreasing, the right sum is going to be the lowest down. So the right sum is going to be the lowest one. Left is highest up, so left is going to be the highest one. So right is going to be the lowest, left is going to be the highest. The true area is going to be somewhere in between, and then trapezoidal is either going to be just above or just below that. And it's going to be just below. If you have something that's concave down and you draw in the trapezoids, they're going to be really slightly underneath. So trapezoidal will be just below the true area, which I was going to put a to b, but I guess we have the actual numbers. It would be from 2 to 4, f of x dx. So this is the lowest, this is the highest, this is the true area. Trapezoidal would just be slightly below that. And so then you can use that to answer these questions. So the left-hand sum is going to be bigger than the right-hand sum. The area under the curve, so that's the integral, that's the true area, is smaller than the left-hand sum. And the area under the curve, again, that's this integral, is going to be bigger than the right-hand sum. What I ask you to do on the test is just list these out in order. So like smallest to biggest. And number 2 is the same type of question as number 1. You would want to draw a picture of that just to get a visual, look at what it's doing, increasing and decreasing its concavity, and then put those in order. All right, so since 2 is kind of the same thing as number 1, we're going to jump down to number 3. So we're going to do all of these sums for this function on the interval 0 to 8. So you're going to need to get all of the values from 0 to 8. And this is non-calculator, so we're going to have to get through plugging all of these in. All right, so if we plug in 0 for x, we're going to get 2. Oh, sorry, I didn't see a question in there. Let me scroll back up. I'm so sorry. I just saw that right now. So why is left the greatest? Because the function is decreasing on that interval, and so the left side is further up than the right side. So left is going to be an overestimate and right is going to be an underestimate. So this is the biggest and this is the smallest. Okay, cool. All right, so we're going to plug in all of these values to this function. So if we plug in 0 for x, we're going to get 2. If we plug in 1, we're going to get 2.5. If we plug in 2, 2 squared is 4. Half of that would be 2, plus 2 is 4. If we plug in 3, that's going to be 9 halves, which would be 4.5, plus 2 would be 6.5. 4 squared is 16. Half of that is 8, plus 2 is 10. 5 squared is 25. Half of that would be 12.5, plus 2 would be 14.5. 6 squared is 36. Half of that would be 18, plus 2 is 20. All right, 7 squared, 49. Half of 49 would be 24.5, plus 2 would be 26.5. And then 8. 8 squared is 64. Half of that is 32 plus 2 is 34. So you have to plug all those in to get the values. And it says we're going to do 4 equal subintervals. So if we went from 0 to 8 to divide that by 4, each subinterval is going to be 2 units. So this is the first one, this is the second one, this is the third one, and this is the fourth one. So the interval is 0 to 8, that's 8 units. We're dividing by 4, so 8 divided by 4 is 2. Each subinterval is 2 units. That's kind of like all the hard work. Now we're going to just write out all these answers. So for the left sum, each subinterval is 2 units in length, so 0 to 2, 2 to 4, so on and so forth. And we're just going to pull out all the left values. So for the first subinterval, that's 2. For the second subinterval, that's 4. For the third one, that's 10. And then for the fourth one, that's 20. And please listen carefully to me. Do not simplify these down on your test. I say this every year, and every year there's somebody that wants to go and add all that together. And the reason it's frustrating is because if you do that, then I have to do that. And I don't want to do more work than I have to. And if you've added wrong, then it's wrong. So please just don't leave that alone. Okay? Right sum is going to be the exact same thing. The subinterval is still 2. We're just going to take all the numbers on the right. So the first one's 4, and then the next one's 10, and then the next one's 20, and then the last one's 34. And then midpoint sum, again, same thing. The subinterval is still 2 units. Now we're going to take the number in the middle. So that's all the ones we didn't use yet, all the ones that have the like 0.5s in there. So 2.5 plus, was it 6.5 plus 14.5 plus 26.5. All right, and then trapezoidal. It's going to have a 1/2 out front. Remember, you have a 1/2 in that formula. The height of each of the trapezoids is the length of the subinterval, which is 2. You'll notice these all have a 2 in. And you're going to use the first and last number once, and then all the ones in the middle get doubled because they're shared between the subintervals. So the 2 is going to just get used once, and then I'm going to double the 4, and then I'm going to double the 10, and then I'm going to double the 20, and then the 34 is just once. Again, please do nothing to that. Please just leave that alone. All right, number 4, 4 and 5 I'm going to skip. We did ones like these in the homework. This is involving your integral properties. For number 5, you would draw that and then find the area from 4 to 7. I think it comes out to be a trapezoid. So you draw the graph and then do the area from 4 to 7. 6, same kind of thing. We're going to draw this graph and do the area from -8 to +8. I just wanted to do this one because it's an absolute value. It's just the regular parent function for absolute value. It's just centered at the origin. It's not stretched or shrunk, just a regular V shape. And we want to do the area from -8 to +8. So what you end up with are these 2 triangles. And so we're going to find those areas and add them together. So a triangle is 1/2 base times height. So since it's an absolute value, if this distance is 8, this distance is also going to be 8. So the base and the height are both 8. So 1/2 times 8 times 8, that's this triangle. And then this triangle is going to be the exact same thing. So you could even think of like putting them together and like making it a square, an 8 by 8 square. Because this is going to come out to 64. This would be 32. This would be 32, so 64. So it's an 8 by 8 square, just kind of 2 triangles there. All right, so for number 7, 7A and B are the same kind of thing, so I was just going to do B. We're going to have to split this where the intersection is. So there's going to be 2 separate integrals that get written. So let me ask you guys a question. What are going to be the boundaries for the first integral? If we're doing this area under here, it would be from where to where? Good, perfect, nice job, 0 to 2. So from here to here, 0 to 2. And we are underneath the parabola for that one, which is the x squared. So x squared dx. Plus, and then we're going to do the second one. So that would be from 2 to 6. And that is under the line, which is this negative x plus 6 dx. And that's all I'm asking for. The common mistake people make with this one is that they then try to do something with it. Don't. All I'm asking you to do is write the integral, write one or more integral expressions. Right? So that's all you have to do. All right, numbers 8, 9, and 10 are indefinite integrals. That means you do the antiderivative and put plus c. So you should all have plus c at the end of them. I'm going to go ahead and rewrite this one, first of all, because it's blurry, and secondly, because we're going to have a negative exponent here. That says 4 over x to the third. So if I rewrite that, it would be 4x to the negative third dx. And I kept the integral symbol and I kept the dx because I didn't actually do the problem yet. I just rewrote it. So you're going to add 1 to the power. So it'll be x to the negative 2. I took this and I added 1. And then I want to divide by negative 2. So my coefficient is 4. 4 divided by negative 2 would be negative 2. And then just put a plus c at the end. You can always do a derivative to check your work. If you do this derivative, when you do a power rule, if you were to multiply the negative 2 down, negative 2 times negative 2 would be 4. That's what you have here. And then you would subtract 1 from the power. Now, I'm going to ask you on the test to fix the negative exponents. You can't leave it like this. So this is going to be negative 2 over x squared plus c. You have a negative exponent, it means you're dividing by that. So it has to go back down to the denominator. So indefinite integrals, you just do the antiderivative and put a plus c at the end. Now, if it is a definite integral, you're going to do fundamental theorem of calculus. So it's upper boundary minus lower boundary. So we're going to do an antiderivative. You won't have a plus c. Instead, you're going to have that such that bar at the end. All right, so here we need a function that if we do the derivative, we're going to get sine. That is going to be negative cosine. The derivative of cosine would be negative sine. So I need a negative there to cancel that out. So again, derivative of cosine is negative sine, but since it's positive sine, I'm going to cancel that out. Minus, and then I need to come up with a function that if I did the derivative, I would get 5x to the fourth. We're going to add 1 to the power. So it'll be x to the fifth. And then you would want to divide by 5. There's already a 5 there, so the 5s would just cancel. So it's just x to the fifth. And then such that negative pi over 2 to pi. So we're going to do upper boundary minus lower boundary. Let me pull out my unit circle. When we do the upper boundary, I already asked you guys this one today. Where's pi? You guys said to the left. That's right here. Cosine is the x value. So that would be negative 1. And then we're going to make that negative. So it's negative 1. So that would just be 1 minus, and then we're plugging in pi. So that would be pi to the fifth. All right, and then lower boundary. Now, negative pi over 2. Let me ask you guys that one. Negative means you're rotating backwards. So using a word like up, down, left, or right, where is negative pi over 2? And good, you wrote that really fast. Good, down. If you're rotating backwards, you're going this way, so it's going to be down here. So here's negative pi over 2. Cosine means the x value, which is 0. And then you can't negative a 0. That's just going to be 0. Minus, and then it's negative pi over 2 to the fifth. I'm going to keep going here. So this would be 1 minus pi to the fifth. Now, if you have an odd exponent, that's going to stay negative. So this would be negative pi over 2 to the fifth. Those negatives are going to cancel, so it would be positive, but then this one makes it negative again. So it's going to be minus pi over fifth, and then if you do 2 to the fifth, that would be 32. But I guess you could stop in the step previously. I do want you to evaluate the trig. So don't leave something as like cosine of pi. I do want you to simplify those down because I need to make sure that you can do the unit circle. But I guess if you stopped on this step, I would take that too. That was a lot of negatives there. All right, and then number 13, antiderivative for 1 over x. That's going to be ln. And then we're going to evaluate from 1 to e to the 7th. So it's upper boundary minus lower boundary. So if we plug in the upper boundary, it's going to be ln e to the 7th minus ln of 1, which is 0. So that's going to be gone. And hey, guys, what's going to happen here? What is this going to reduce down to? ln e to the 7th. What's that going to be? Good, 7. The ln and the e cancel. Perfect. So that is just going to be 7. Nice job. All right, almost done. Hang in there. All right, find the average value for this function on the interval 0 to 8. So that's going to be 1 over 8 minus 0, integral 0 to 8. Again, make sure these numbers match. And I'm going to rewrite this instead of cube root of x. I'm going to write it as x to the 1/3. So like a square root is to the 1/2, a cube root is to the 1/4, a fourth root is to the 1/4, you know, so on. So out front, we're going to have a 1/8, and then we're going to do this antiderivative. So it's going to be fun with fractions here. We're going to add 1 to the power. So it would be 1 1/3, which is 4/3. And so I would need a 3/4 out front. We're going to evaluate that 0 to 8. So first, we multiply these fractions out front. This would be 3 over 32. And then this is a cube root of 8 to the 4th. So it is cube root of 8 to the 4th power. The denominator tells you what type of root. It's going to have to be the same as it was in the problem. It can't change. So if it was a cube root here, it's going to be a cube root here. And then this numerator tells you what power. So to the 4th. That's your upper boundary. Minus, now you catch a break here because if you plug in 0 for x, the whole thing is just going to be 0. So it's going to just be gone. All right, and then let's see. Cube root of 8 is 2. And 2 to the 4th would be 16. So this would be 3 over 32 times 16. 16 times 3 would be 48. So 48 over 32, which, gosh, let me see. What are those both going to divide by? Well, they'll both divide by 16. So that's going to be 3/2 for that if you simplify the whole way down. But in all honesty, again, if you stopped way back here, I'd have to accept that. I can't fault you for that. You don't technically have to evaluate them. But since I'm going over it here for you, I just figured I would go the whole way. All right, number 15 is also an average value. So it's going to be, you know, same setup as we just did for 14, but I did the more difficult of the two. This one's not going to be as bad. So we'll skip that one and go on to 16. A car is slowing down as it approaches a red light at an intersection. So pretend you're in a car, you see a red light, you hit the brakes, you're still going forwards. Notice all these velocities are still positive. Your car doesn't start going backwards, right? But you are slowing down because you've hit the brakes. So the velocity is getting smaller and smaller. So you're heading towards the red light, you're still going forwards, but you're slowing down. So approximate the distance traveled in the first 15 seconds using a right sum with these 5 sub-intervals. We're going to have to do all 5 of them separately because they're not all uniform. This is not counting by the same number each time. All right, so the first sub-interval from 0 to 2, that's a distance of 2. And this said to do a right sum. So the number on the right is 40. And then the next sub-interval from 2 to 6, that's a distance of 4. The number on the right is 28. From 6 to 7, that's 1. The number on the right is 19. From 7 to 10, that's 3. The number on the right is 11. And then from 10 to 15 is 5, and the number on the right is 5. Now you do need to put units. Please, again, please, I'm begging, don't do anything to this. It is so much easier for me to grade if you just leave it alone. If you mess with this, I'm gonna have to do it, and then you're causing me more work. Please don't, just leave that alone. But you do have to put units. All right, now this is like the AP one we just went over. This is in feet per second. We approximated just the distance, which would just be feet. We did an approximation of an integral. So if you have velocity and you do an integral, it's going to just take you back to feet. If you do a derivative, which I'm going to get to in a second, you'll have feet per second squared. Okay, let me write that down again because that's worth talking about. You have velocity, that's feet per second. If you do a derivative, it's feet per second squared. And if you do an integral, then it's just feet. So you have feet per second squared. So letter B says, is that answer an overestimate or an underestimate justify? Okay, we had some trouble with this when we did the other one, so let's look at this really carefully. These numbers are decreasing, so you can just go like that. We have a decreasing function. Think about what kind of a sum we did. Is it going to be under or over, guys? These values are decreasing. Look at what kind of sum we did. Is it under or over? All right, good, we got there, we fixed that. All right, so since we did a right sum and the function is decreasing, the right side is lower down, that's going to be under. So it's under because velocity is decreasing, and this is a right sum. All right, perfect. And then C, approximate the acceleration. So this is going to be feet per second squared at time 12. We can't do a derivative because we don't have a function. So how do we approximate a derivative? This was another one we had some trouble with earlier, so I'm asking again. Derivative means what? What are we going to do? Good, nice, slope, perfect, awesome, good job. Derivative means slope. Now it says at 12. 12 is not on the table, so you have to find the numbers around 12. 12 would be in between here somewhere. So we're going to use this point and this point. So I always write them down. So we've got 10, 11, and we've got 15, 5. And we're just going to do a slope. So it's going to be 5 minus 11 over 15 minus 10. Do nothing to that. If you subtract wrong, it's wrong. So just leave it alone and put the units. So feet per second squared. All right, and then this last one here, we're going to use the graph to answer the questions. So the first thing you need to do is find these areas. So we have a triangle and we have a semicircle. So triangle is going to be 1/2 base times height. So the base is 6 and the height is 2. So the 1/2 and the 2 cancel, that's just going to be 6. And then a semicircle. Now a whole circle would be pi r squared. So a half a circle is 1/2 pi r squared. And so all you need to do is find the radius of the circle, which is going to be 3. So that is 3 squared is 9. That's 9/2 pi, but it's going to be negative 9/2 pi because that is below the x-axis. So it's like an unaccumulation, like money out of the bank. Now that's the hard part. Once you have that, you just use it to answer the question. So this first one, we want to go from -4 to 8. So that's the whole thing. So that would just be 6 minus 9/2 pi. And then absolute value means you're going to just treat the whole thing like it's positive. So it'll be 6 plus 9/2 pi. Again, still going from -4 to 8. So it's from here to here. It's the whole thing. And then this one from 2 to -4. So if we go from 2 to -4, we're going backwards. So that would be -6. And then the last one, average value from -4 to 8. So we're going to need to put that fraction out front to make it an average. 1/8 minus -4. So it'll be 8 plus 4. Integral -4 to 8 f of x dx. So the fraction out front is 1/12. And then this we've already answered. From -4 to 8, we said was this. So 6 minus 9/2 pi. The common mistake I get on this question, and it's funny to me because people will answer these like perfectly and then get down here and have the 1/12, but then try to do something else with this. Just remember, you've already answered it. It's right here. So just copy that down for that part, and then you can leave that in.